left off, did we get someplace like on number 60? Does that sound right? 56, 60.
Yeah.
Where did we get to? 64? Okay. So, how are you doing with those things? Those kind of problems? Are you able to expand them pretty good? Okay. I'll do 68 just to kind of talk about a little of the factoring part. So it's 5a plus 6 times 6a plus 5. And this thing is a FOIL, so it's the first terms times each other, which is 30a squared. Then the outside is plus 25a plus inside is 36a. And the last 6 times 5 is 30. So it's 30a squared plus combining terms. I think that's 61, isn't it? 61a plus 30. Now if you're going to factor it, remember that that's at going right to left. That's at 6a. No, it's 6b, trial and error. That's where you'd have to do it. And so what you do is you say, if this thing factors into a binomial product of two binomials, then the first term of the binomials has got to be an A. And then you're going to have a number here because you got this 30 up front, and a number there to get to 30. And then this, you're going to figure out what sign do you put beside this. This is a plus right here. That means they have to be the same sign, both negatives, both positives, in order to get a positive. Well, which one is it? You look here and that's a positive. So that says you put a plus and a plus. Now, you got to figure out what numbers go there. The product has got to be this 30. But, you know, the combination sum has got to be 61. So what you do is you factor. You prime factor this 30. It's 1 into a pair of integers. 1 and 30, 2 and 15, and 3 and 10. In the same way here. 1 and 30, 2 and 15, and 3 and 10. And then you have to go with this pair, 1 and 30, and look at 1 and 30 over here, and you say, is there a combination such that it's a 61? Well, if you did this one times this one is 1, and then 30 times 30, you'd be a huge number, right? It wouldn't work. If you did this 1 times 30, and you did this 30 times 1, you'd be 60 and you'd be 1 short. That will not work. So if you do 1 and 30 and 3 and 15, if you did 1 times 3, 3, 30 times 15, well, you'd be way high, okay, when you added those. Because 30 times 15 would be 450. So if you did the 2 times the 15, and then this 15 times this 2, you'd be short, because you'd be 30 plus 30. That would be short. I think I jumped down one. Okay. Then you would try this 1 and 30 with this 3 and 10. And if you did 1 times 3 and then 30 times 10, that don't work. You did 30 times 3, that just puts you too high right away. So that, then you try the 2 and 15 and the 1 and 30. Yeah. Somehow I'm doing this. I missed one, 5 and 6. There's 5 and 6. But ultimately, when you did your combinations, you'd find that this 5 and 6 and this 5 and 6 does the 31. Because you do the 6 times the 6 is 36, and the 5 times the 5 is 25, and that would get you the right number in the middle, the 61. Then you put the 5 and 6 here, and then you put the 6 and 5. I didn't do a very good job of explaining it, but that's a way. That'd be a pretty complicated problem to try to figure out. But what you're going to have to do is what we learned in the next chapter is for most problems, well, for all problems, you're going to have an equal sign. You're going to have this kind of a problem right here, where it has an equal to, and ultimately you'll be equal to 0. You'll prime factor it into 2 factors that's equal to 0, and then you will take each one of these factors, one or the other has to be 0. You'll set it equal to 0, and you get values for A, which will be your solutions. So you've got to be able to factor, but you've got to be able to expand and move it around so that you get this 0 by itself. Because if you notice in the algorithm, the algorithm goes, number 1 is expand, number 2 is get 0 by itself on one side of the equation. That's what this algorithm sheet says. And then it says, write it in descending order, do a common factor, and then you do the binomial factorization and so on. So that's the process of solving this. And what we're learning is how to expand and how to factor in these 2 chapters. Okay. I'm going to say that you know how, you can probably figure out the rest of them through 82. Now, I'm going to look at 86. If you look in your factoring algorithm, is going to be that 5A. If you go on the right-hand side, notice it says a binomial sum times a binomial difference, where the A and B are the same numbers. And notice 86, you have a binomial sum, y plus 6, and then you have y minus 6. You see, this y is A, 6 is B. We said y was A, and then minus B. So whenever it's like that, then it will always expand. If you go to the left-hand side, you see it says it always expands to A squared minus B squared. This thing always expands to A squared minus B squared. Now I'll just go ahead and FOIL this to show you what it is. You take the first terms times each other, the outside terms, the inside terms, and the last terms. Notice these 2 go to 0, and it's y squared minus 36. So whenever you see y plus 6, y minus 6, you can automatically go right down there. It's the first term times, it's the first term squared minus the second term squared. Now, if you're factoring it and you see it this way, you say, is the first term a squared term? What is it? y. Is the second term a squared term? Yes, it's a 6. It's a difference. So therefore, it's going to be y plus 6, y minus 6 is out backwards. That's the way you look at it. So let's expand 88. Is 4y minus 7 4x plus 7. Notice this is an a minus b times a plus b. So how is it going to expand? It's going to expand into the first term squared minus the second term squared. So the square of the first term is 16x squared, and the square of the second term is 49. You don't have to FOIL it, you just run it out that way. Then when you're factoring, what you do is you'd say, that's a squared term, that's a squared term, it's a difference. Therefore, it's going to fit into the pattern of a plus b, a minus b is equal to a squared minus b squared. This is a squared, this is a squared. The thing that's squared here is 4x, the thing that's squared here is a 7. So therefore, it's going to be 4x plus 7, 4x minus 7. Because it's in this pattern. And that's how you factor it. That's what you look for. Now 90, notice it's a binomial difference squared. And if you look in your factoring algorithm, and you look at 6a2, a minus b, the quantity squared. See, it says this. It says if you have a minus b, the quantity squared, it's going to expand into a squared, first term squared, minus 2 times the product of the first times the second, plus the second term squared. That's the way you want to remember it in words, because then you can expand anything. So if you look at 90, 90 is y minus 3, the quantity squared. What it expands into the first term squared. That says, what is it? Y squared minus 2 times the product of the first y times the second 3 plus the second term squared, which is 3 squared. If you remember it in words, you can write it out. So this is y squared minus 6y plus 9. You can expand it. Now when you're going the other way, you're going from this thing to factor it. You say the first term is a squared term. Y is being squared. The last term is a squared term, it's 3. Then you would check, is the middle term 2 times the first times the last, and you'd say it is. This is a negative, so it's a binomial difference of the first term, the square root of the first and the square root of the second, and so it's that. Which way you want to look at it. So let's look at 93. See what you can tell me how to do this. This is 3x minus 7, 3x plus 7. It's a binomial difference times a binomial sum. So how are you going to expand that? First term, what? Squared, right? So it's 3x, the quantity squared. Then what's the middle term going to be? Negative what? 2 times the first term times the second term. And then what? Plus, see, this is a squared minus 2ab plus b squared. So what am I going to do over here? 7 squared, isn't it? Because this is a minus b, a plus b. And I just simplify this. 3x quantity squared is 9x squared. Minus 2 times 3 times 7 is a minus 2 times 3 is 6. 6 times 7 is 42x plus 7 squared is 49. Now when I'm looking at trying to factor this, I look at this and I say that first term is a squared term. It's 3x. Then I look at this last term and I say it's squared. It's 7. To see whether it is this pattern, a minus b, a plus b, this middle term would have to be 2 times 3x times 7. And I would say 2 times 3 is 6, times 7 is 42. Sure enough, it's 42x. Therefore, this is going to factor into 3x plus 7, 3x minus 7. And that's the way you got to look at the problem. Okay. Any questions on that? I don't know how much you know about this stuff ahead of time, but usually in this algorithm it'd be really important when we're doing the problems in 7 on being able to solve that. 102. It says the width of a rectangle is x minus 6. The length is 2x plus 3. So it says the width is x minus 6. So this width right here is x minus 6. And the length is 2x plus 3. And it's saying find the area. So what's the formula for area? Area is what? Length times width, right? Length times width, right? So the length is 2x plus 3, and the width is x plus minus 6. So then we would expand it, right? That expansion has to use what? FOIL. So it's the first term, so that'd be 2x squared outside minus 12x inside 3x last minus 18. And if we simplified it, it's 2x squared, then minus 9x minus 18. And that's what they're looking for. So 108, here it says a triangle. It's best to draw something out. It says the base is 2x plus 6. So this is 2x plus 6. And then this height is x minus 8. And it's saying find the area. So what's the formula for area? 1/2 base times height, right? Now remember to put that 1/2 in. Remember that you're doing a triangle, not a rectangle. So then this is 1/2, the base is 2x plus 6, and then the height is x minus 8. Now you could FOIL this thing out and then take 1/2 of it. What's another thing you could do? You could take the 1/2 times the 2x plus 6, right? Make this x plus 3 times x minus 8. Is that right? That would make it a lot simpler. So I multiply these two together first. So now then the first term is x squared. Outside is minus 8x. Inside 3x. And then it's a minus 24. So it's x squared minus 5x, isn't it? Did I do it right? It's not wrong to do it the other way, it's just a little bit less numbers involved. So is there any problems that you want to see? Are you understanding everything that you think you can do all the problems? Okay. So the next set of problems, the 6-4, it's talking about long division and synthetic division. Long division is on A and synthetic's on B. Now, just something about synthetic division, which is, and then when I do problems, give you problems, you do it whichever way is easiest. You do long division if I give you a division problem, or if it fits the criteria for synthetic, then do synthetic. Now what you have to have is, I'm going to take like number 2, and I'm going to show you x squared minus 14x plus 24. And it's saying divide by x minus 2. Now you can do this either of two ways. You can either do it long or do it synthetic. Synthetic is a special case. Synthetic division requires this term to be a binomial, x minus a. In other words, this number out front here has got to be 1, the numerical coefficient. This has got to be a linear. So it's got to be a linear binomial with a numerical coefficient of 1 on your variable term. If it fits that criteria, then you can do synthetic division. So I want to test whether you understand what I just talked about. Caleb, number 1, would you be able to divide number 1 synthetically?
You would, yeah.
Yeah, because it's a linear binomial with that numerical coefficient. Damon, number 2. Okay. Then next, number 3. Could you synthetically divide that?
Yes.
Okay. Number 4. Elisa.
Yes.
Whitney, number 5.
Yes.
How many say yes for number 5? Do you want to reconsider, Whitney?
No.
Okay. How many say no? You see it has that 2 in front of that x. You see that, Whitney? If it were just the 2 or 1, if it was x plus 1, you could synthetically divide, right? Julissa, number 6.
I want to say yes.
How many say yes? How many say no?
Maybe it's no. I think the answer is no.
Why? Why do you change your answer?
Okay.
What?
But it's not yet.
Well, why is it not yes? Carly, can you tell her why it's not yes? Carissa, can you tell us why it's not yes?
Because it doesn't divide into
That, it just felt, what, say it
it.
again.
Doesn't divide into it.
Okay, that 3x minus 2, that 3 would have to be a 1. And then it's x to the first part is fine. So if it were 1, if it were x minus 2, you could do it. Does that, do you understand, Julissa?
Yeah.
The 3, that numerical coefficient of 3 makes it not possible.
Okay.
Okay. So number 7. Carly, number 7, can you synthetically divide that?
I don't think so.
Why? Why don't you think so?
You just said that it has to be minus 1 or plus 1. You said something
Actually,
else.
the 2x, the 2 in front of that x would have to be a 1. It has to be a linear, but it has to have a numerical coefficient of 1. So rather than 2x minus 1, it'd have to be x minus 1. Do you understand, Carly?
Yeah.
Okay. All right, so then number 8, Carissa. No, because what's wrong with it?
3.
Okay, is everyone getting it? So you can just go down through. Now this is synthetic division when you get into big problems like 17, 18, and on down. Synthetic division is a little quicker than long division. Now I'll take this problem and I'll do it both ways. I'll do synthetic and I'll do long division. First of all, I'll do long division. So long division, you take your divisor x minus 2 and you just set it up like normal division. Now, I want to do just a number normal division problem. I want to go 5 into 231. You would go 5, don't go in for 2, right? Then you go 5 into 23, what, how many times? What would you do? There's a point in this, it's easy. It's 4, and then you go 4 times 5 is 20. Now, do you add that or subtract that? Why? It says plus right out here.
But division.
What do you always do when you divide? You always, where that circle is, change that to a negative, even though it's positive, right? That point's going to follow us right into what I'm going to do in this long division. Now then you'll go 3, 1, and you go what? 6. Then you'll go 30, and you'll change the sign. 1, and then you would go 1/5. Is that right? I mean, you could go decimal, but I'm just saying no decimals, then you do that. So now let's do this long division. You take this thing and you look at that and you say, what would I have to do with this leading term in my divisor to make it equal to my leading term in my dividend? What would I have to multiply this by? I'd have to multiply it by an x. Now if I take this x times that leading term, I would get x squared, correct? And if I take this x times that minus 2, I'd get a minus 2x. Now what do I have to do? You have to subtract, so that means you've got to change the signs, right? Just like you changed the sign in that division. There was a point of doing it. I want you to see that you always do it when you're doing it normally, but you don't think about changing the signs. So now this becomes 0. Now this will better happen every darn time. Because you see, what do you always do? You always eliminate this part, right? Goes to 0, correct? So it better go to 0. If it don't go to 0, you've done it wrong. You gotta go back and multiply by something else, right? Now then, combining these next, it's a minus 14x plus 2x is a minus 12x. Then you bring down the next term. Just like you bring down terms, right? You brought this one down here. And then what you do is you say, what do I multiply this x by to get this term so it goes away? What I do? Minus 12, right? I got to go minus 12. Then I get minus 12x, and I multiply this times that, and then a plus 24. Now what do I have to do? Change the sign. Don't forget to do that. Because and this is a minus. That makes this one go away, right? It better go away. And then this one goes away, so it's 0. So my remainder is 0. So this is my answer. Does that make sense? Now let's do it synthetically. Now, synthetic division, what you would do, you just reverse an L. You take whatever this number is right here. You notice it's a minus 2. You change the sign to plus 2. Now, you see what you're doing in the process. We change signs all the time here. You change signs once right there, doing that. Does that make sense? That takes care of the sign change. Now, what I do is above, there's going to be a row across here, but above that row, I write the leading numerical coefficient is a squared term. Then it's a linear term, and then it's a constant term. I just call that a cheat row. When you look in a book or something, you talk synthetic division, they will never do that. But I think that it will become clear why it's good. Now, under this thing right here, I take the numerical coefficient right here and put it right down here. What am I going to put? What's in front of that x squared term right there? 1. What's in front of this x term? Negative 14. What's the constant term? 24. Now I'm ready to synthetically divide. I'm going to have 2 more rows. Now what I'll do is I'll bring this first term straight down. And I'll just bring it down as a 1. Then I'll multiply this 2 times that 1, and I'll put it right up there. So it becomes 2. And then I'll add those 2 together, and I'll get what? 12. You see what I've done is I got this right here is this right here. Is this right here. You see that? Now if I multiply 2 times 12, I get 24. Someplace, this is a minus, this is a minus. So I've got this term right here. And then this is 0. Now to pick up my answer, I put this numerical coefficient of 1 times 1 degree less than this right up here, x. Then I put the numerical coefficient 12, minus 12. 1 degree less than that, which is x0. So this is really x minus 12. It goes a lot faster now. Does that make sense? So I'm going to do number 4. 4 says, I'm going to do synthetically because it's able to, because it's quicker in my point. I'll do it the other way too if you want me to. x plus 4. Now synthetically, I would reverse this, I would go minus 4, right? Then I'm going to put my cheat row, x cubed, x squared, x to the first, and x 0. Now my cube term, in front of that cube term is a what? 1. In front of that squared term is a 4. In front of the linear term, they don't exist. If it don't exist, what has it got to be? 0 times x. This has to be 0. That's a minus 8. If you don't put that cheat row up here, you'll never remember to put that 0. What you will have is a problem that looks like this. And you'll synthetically divide into that. That'll be this is totally different than what I'm going to get. Do you see that? You'll miss that 0 about over 50% of the time. And I bring my 1 down. This is a minus 4, it's 0. Then this is 0, 0. And then it's 0 again. It's a minus 8. So drop that degree by 1. This is x squared with the remainder of, see, it's squared, linear, constant, remainder. And it's 8 over x plus 4. Okay, I got time to do that. I'll do it long division. You do x plus 4 over x cubed plus 4x squared. And then technically I have to put a 0 times x plus minus 8. Huh. And if I do it long division, this here is squared, right? X squared. X squared times this is x cubed. X squared times the 4 is a plus 4x squared. What do I do? Change my signs. This goes away, so I bring down a plus 0 times x. This is going to be 0, so I got to, see, I have a 0 times x, and a 0 here, and then I got this minus 8 hanging out here, and that's a remainder, right? This is plus a minus 8 over x plus 4. That makes sense? Either way, you can do it either way. After a while, when you do those bigger problems, it's going to be easier whenever you can to do synthetic division. Just by way of an example, just look at 18. 18, I can do it in the few minutes that we have left. Notice it says x minus x squared plus 5x cubed plus 3x4 minus 2, and they want that to be divided by x plus 2. So synthetic division, I do what? I put a minus 2 out here. Now notice this is a 4th degree. So I got it, my cheat row's got to be x4, x3, x2, x1, x0. Now, what's the numerical coefficient of x4? 3, right? For x3, what is it? 5. For x squared, minus 1. For x, it's 1, and the constant term is minus 2, right? When I do synthetic division, I bring the 3 down, pull minus 2 times 3 is a -6, I got a -1, then this is gonna be a +2, +1, -2, -1, +2, 0, and then this is 3x cubed minus x squared plus x minus 1 with the remainder 0. Whole lot faster than doing it long division, isn't it? Right? I mean, when you can do synthetic division, and it's a, quadrinomial or 5 terms, boy, you do it synthetic, because it's quick. Does that make sense? I think we can finish this Monday. Now, if I went too fast, if there's something you want to look at, be sure and tell me. I can clear it up on Monday.